Alright, boys and girls, welcome to our third video lesson in Chapter 7, Introduction to Matrices. No, it's not a movie, it's matrices. Okay, a matrix is a rectangular arrangement of numbers in rows and columns. It's numbers with no frills, and again, we'll talk a lot about this in class, but it's a numbers with no frills. The matrices are because it allows us to organize our data in clear and concise manner, and because there's no words, no labels, no nothing, it's numbers with no frills. We're allowed to do a lot of math with these numbers. So I can take a bunch of data, put that data into a matrix, and I can add, I can subtract, and I can multiply. I also now, we're going to learn how to do this, use matrices to solve systems. The dimensions of a matrix is always the number of rows by the number of columns. So it's the number of rows by the number of columns. Okay? This is a 4 by 3 matrix. It's a 4 by 3 matrix because it has 4 rows and it has 3 columns. In other words, it has 4 rows. Right here, here's my first row, my second row, my third row, and my fourth row, and 3 columns. 1, 2, and 3. So this is a 4 by 3 matrix. Okay, and matrices can come in any size or have as many rows and columns as we need. There are some special matrices. There's a square matrix where the number of rows and columns are equal. This, for example, is a 3 by 3 matrix because it has 3 rows, 1, 2, and 3. And 3 columns, 1, 2, and 3, so it's a 3 by 3 matrix. The number of rows is equal to the number of columns, so it's a square matrix. This right here is a row matrix because it only has 1 row. It has 5 columns, but it only has 1 row. Okay, so this is actually a 1 by 5 matrix. And this matrix right here in blue is a column matrix because it only has 1 column. It has 3 rows, so it's a 3 by 1 matrix. Alright, so you tell me real quick, write it down, see if you can get these right. Tell me the dimension of each matrix. I'll give you about 20 seconds here, not even that long. I'll be bored out of my skull. I hope you've written something down by now. Alright, I'll stop talking. Alright, the first matrix is a 3 by 2 matrix, and that's because it has 3 columns. 3 rows. My first row, my second row, and my third row. It also has 2 columns, my first column and my second column, so it's a 3 by 2 matrix. The second one now is a 1, 2, 3, 4, 5, 6 rows, and 1, 2, 3, 4, 5 columns. It's a 6 by 5 matrix. And we can see now we have 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows, 1 column, 2 column, 3 column, 4 column, 5 columns. So it's a 6 by 5 matrix. The elements of a matrix are each little piece of data. So this matrix, which is a 4 by 3, we can see it's a 4 by 3 matrix, okay, is going to have 12 elements. My first element is right here. This is element 1-1. This is element 1-2. This element is 1-3. This element is 2-1. 2-2 because it's the second row, second column. This is element 2-3 because it's the second row, third column. A42, or element 42, is going to be this column. This number right here is 1 because it's in the fourth row and the second column. Moving right along. If I have equivalent matrices, then all the corresponding elements are equal. So, if matrix A is equal to matrix B, that means they are equivalent matrices. That now means that the first element, element 1, 1, and element 1, 1 here, they would have to be the same, so A would have to equal 6. Likewise, B, which is element 1-2, would have to be would correspond to element 1-2 here, which is 5. So B would equal, I got it right. B would equal 5. C would equal 4. D would equal 3. E would equal 2. And F, as in frog, would equal 1. Alright, does that make sense? Let's keep moving. Scalar multiplication is when a matrix is multiplied by a number. When a number is just a number, we call that a scalar. Okay, the multiplication of scalar multiplication is done by multiplying each element by the scalar value. It's like distributing. So if I want to multiply this matrix here by 5, I'm going to basically multiply each of my elements by 5. I'm just going to distribute that 5 through to each of my elements. So I have 5, A11, 5A12, 5A21, etc. If that makes sense. Let's try one. So if I want to multiply this matrix by 3, I'm just going to take my first, well, let's keep my pointer. I'm going to take my first element right here and multiply that by 3. So my resulting matrix is still going to be a 2 by 3 matrix. So that the first one is 3. Now 3 times neg 3 is neg 9. 3 times 6 is 18. 3 times 9 is 27. 3 times neg 1 is neg 3. And 3 times 4 is 12. So my resulting matrix, notice that the dimensions have not changed, but it's just the matrix is 3 times bigger. Each element is 3 times bigger. You guys try that one. Go ahead and multiply that matrix by neg 8. I'll give you a second here. You can stop the tape if you need to. All I'm going to do is I'm going to distribute my 8 to each of my elements. It's still going to be a 3 by 2 matrix when I'm all done. Okay, but 8 times 0 is 0. 8 times neg 2 is neg 16. 8 times, I messed up. Negative 8 times neg 2 is positive 16. Negative 8 times 4 is negative 32. Negative 8 times positive 1/2 is negative 4. Negative 8 times neg 1 is pos 8. And negative 8 times pos 3 is neg 24. So my resulting matrix, that's a 4. My resulting matrix is right there. It is negative 8 times bigger than the first matrix. Okay, matrix addition. We can add and subtract matrices only if they have the same dimensions, if they are the same size. So what must be true in order to add matrices? They must be the same size. They must have the same dimensions. To add the two matrices, all we do is simply add the corresponding elements. Let's try. Okay, let's try one. So we're looking here. We're going to add these two matrices. This is a 3 by 2 matrix. This is a 3 by 2 matrix. We can see that both of these are 3 by 2, 3 rows by 2 columns. Okay, they have the same size, so we can add them, and all we're going to do now is add the corresponding elements. So I have 5 plus neg 2. It's 5 plus neg 2. I have neg 3 plus 1. Neg 3 plus 1, neg 3 plus 3, 4 plus 0, etc., 0 plus 4, 7 plus neg 3. I add those up, and my resulting matrix is right here. And notice that it is still a 3 by 2 matrix. The resulting matrix when we add is the same size. So let's try this one right here. First of all, can I add these two matrices? Yes, I can. This is a 2 by 2 matrix. The second one is also a 2 by 2 matrix. So they have the same sizes, so I can add them. My resulting matrix is going to be a 2 by 2. So all I'm going to do now is add. 4 plus 2 is 6. That's my first element. 2 plus 8 is 10. Negative 9 plus 4 is negative 5. And 5 plus 8 is 13. So my resulting matrix is 6, 10, negative 5, comma 13. And we don't throw a comma in there. Can I add these two matrices? Well, let's figure out the size of the first one. The first one is a 3, has 3 rows by 2 columns. The second matrix is a 3 by 3 matrix because it has 3 rows and 3 columns. Notice that the sizes, the dimensions are not the same, so therefore, guess what? We can't do that. We can't add those. Gotta love that. Can I subtract these? Sure I can. The first matrix is a 2 by 3. 2 rows and 3 columns. The second matrix is a 2 by 3. So my resulting matrix, I'm going to subtract my corresponding elements, is also going to be a 2 by 3 matrix when I'm all said and done. 2 minus 2 is 0. That's the first element. My second element is negative 1 minus 9, which is negative 10. My third element is 7 minus 3, which is 4. Go down here now to the second row. 5 minus 5 is positive 10. 5 minus 2 is 3. That's wrong. Messed up, sorry. 8 minus 2 is 6. And lastly, 2 minus negative 2 is positive 4. So my resulting matrix is 0, negative 10, 4, 10, 6, 4. Alrighty. Okay, let's do one here. I'm going to let you guys do this one, but this is going to be a two-stepper. First, I need to do some scalar multiplication, so I need to multiply the first matrix by 6. Okay, and then I'm going to add my two resulting matrices. Okay, notice that both matrices right now are 2 by 2. When I do a scalar multiplication, that does not change the size of my matrix, so I'm going to have a 2 by 2 plus a 2 by 2. So my resulting matrix has got to equal a 2 by 2 matrix. Go ahead, stop the tape, and see what you can do. Okay, you should have gotten a 2 by 2 matrix. 8, negative 2, 2, 23. We just multiplied our first matrix by 6. Our resulting matrix is right here, 6, 0, 0, 24. I then added these two matrices, all the corresponding elements. So 6 and 2 became 8. 0 and negative 2 became negative 2. 0 and 2 became 2. And 24 and negative 1 become 23. So there's my resulting 2 by 2 matrix. Okay. We've done quite a bit. After this video, you should understand what a matrix is and the element of a matrix. You should be able to also tell me the size of a matrix. You should understand scalar multiplication. Please note the size of a matrix does not change when I perform scalar multiplications. Equivalent matrices mean the matrices are the same matrix, so all the corresponding elements are the same. We know how to do addition and subtraction of matrices. Yes, the sizes of the matrices must be the same. And in class, we will do matrix multiplication because it's a little more difficult than what we've done. So we will do that in class. Alrighty, folks, that's it. We'll see you soon.